Let's go ahead and solve number 23 in lesson 2.3. I want to prove that the limit as x goes to 1/3 of the function 1 over x equals the number 3. So I take the absolute value of 1 over x minus 3 is less than epsilon. I'm going to get common denominators now. When I do that, I get the absolute value of 1 minus 3x over x is less than epsilon. I'm going to factor a 1/3 from the numerator. So now that gives me 3 times the absolute value of 1/3 minus x over the absolute value of x is less than epsilon. Because we're dealing with absolute values, 1/3 minus x will give you the same value as x minus 1/3 because an absolute value is always positive. So in other words, I'm allowed to switch the x and the minus 1/3 to make it look more like what I'm shooting for. I'm shooting for x minus a in the absolute value, and my a value is 1/3. Now the goal is to make 3 over the absolute value of x as large as possible so that when we divide that large number to the right hand side, something small divided by something large is something even smaller. Now here I'm going to choose delta equals 1/6. Why? Well, I'm going to explain why, but I'm going to explain later. So let's follow the choosing of delta equals 1/6. Let's follow that now, okay? Choose delta equals 1/6, then the absolute value of x minus 1/3 is less than 1/6. This means that x minus 1/3 is bounded between 1/6 and negative 1/6. Add 1/3 everywhere, and I have x is between 1/6 and 1/2. Now look at those two numbers, 1/6 and 1/2. Remember, I want 3 over x to be as big as possible. But the absolute value of x is in the denominator. So the choice that I want to make here is actually a small number, because when you divide by a small number, you get a bigger number. So my choice then is 1/6, because 3 divided by 1/6 is 18, and that's a pretty big number. What if I'd chosen 1/2? Then 3 divided by 1/2 would have been 6, and 6 is smaller than 18, and that's why I choose 1/6. So now I have 18 times the absolute value of x minus 1/3 is less than epsilon. Divide both sides by 18, and now I've found my delta. The absolute value of x minus 1/3 is less than epsilon over 18. So I let delta become the minimum of one of the two values. Is the smallest 1/6? Then I choose that. Is the smallest epsilon over 18? Then I choose that. And that proves it. Okay. Why on earth am I choosing 1/6 instead of 1? Because so many times in previous problems I chose 1. Well, let's look at the consequence of what happens if I do choose delta equals 1. If I choose delta equals 1, this means that x minus 1/3 is bounded between negative 1 and 1. Add 1/3 to every side, and I get negative 2/3 is less than x is less than 4/3. Now remember the goal. The goal is to make 3 over the absolute value of x as big as possible. Well, negative 2/3 isn't going to do it because the absolute value of negative 2/3 is 2/3. And 4/3 isn't going to do it either. There's actually a number in this interval that makes 3 over x as big as possible. Do you know what that number is? It's 0. Because 3 divided by the absolute value of 0 would be positive infinity. It would be undefined, and that's as big as you can get. And that's a major problem because we're not allowed to divide by 0. And so when we choose 1/6 instead of 1, what we do is we end up pushing 0 out of our interval. 0 is no longer an option. It's no longer a choice. And that's why we chose 1/6 instead of 1. So the moral of the story is that you do get to choose delta arbitrarily, but only arbitrarily up to a point, which sounds like a contradiction. And I guess it is. Choose delta in such a way that it pushes 0 out of your interval, or it pushes the number that would make the denominator 0 out of your interval. That's probably a better way to say it. All right, that is the proof.